Determine the left-sided limit and the right-sided limit, and the two-sided limit as x approaches pi of sine of x divided by cosine of x plus 1. Each of these involves the limit as x approaches pi of sine of x divided by the cosine of x plus 1. The first thing to do is try plugging a pi in for each of the x's. That will give the sine of pi divided by the cosine of pi plus 1. The sine of pi is a 0. The cosine of pi is a -1 and then plus 1. And -1 plus 1 is a 0. Given the 0 over 0 indeterminate form, we will have to rework this. Since neither trig function is squared, we cannot use a Pythagorean trig identity. Since neither trig function is of a 2x, we cannot make use of a double angle identity. But we do have a trig combination, a trig function, sine or cosine, added or subtracted together with a 1. It's happening in the denominator here, that cosine of x plus 1 trig combination, which means that we can make use of a trig conjugate. I will rewrite the exact limit as given. The trig conjugate of the trig combination will be the same two terms, but opposite sign between them, so cosine of x minus 1. We will put it over itself so that we have a form of 1, so that when we multiply by it, we're not changing the value, just the look. In the numerator, those are not trig conjugates of each other, so we will not distribute, but rather keep it factored. In the denominator, those are trig conjugates. We will FOIL that out. First, cosine times cosine, cosine squared of x. Outside, cosine of x times a -1 is a negative cosine of x. Inside, plus 1 times cosine of x is plus cosine of x. And then last, positive 1 times -1 is a -1. The outside and inside terms are equal value, opposite sign. They will always be able to cancel. And this is going to become, leaving the numerator factored, sine of x times cosine of x minus 1 divided by cosine squared of x minus 1. The denominator now has a Pythagorean trig identity that can be used. The original is sine squared of x plus cosine squared of x equals to 1. To produce what we have, we need to subtract 1 from both sides, which will then move the 1 over with the cosine squared of x, and then subtract both sides with sine squared of x. So we sort of interchange the 1 and the sine squared of x onto the other side, and they both become negative. But cosine squared of x minus 1 is equal to negative sine squared of x, so we can replace that in our denominator. So we have the limit as x approaches pi of sine of x times cosine of x minus 1 divided what will now be a negative sine squared of x. We still have the 0 over 0 indeterminate form because sine of pi is a 0, but we have a sign in the numerator that can cancel with one of the signs in the denominator, removing the 0 over 0 indeterminate form. What is left will be cosine of x minus 1 divided by negative sine of x. We can now try plugging a pi in for the remaining x's, which will give cosine of pi minus 1 divided by negative sine of pi. Cosine of pi is a -1 minus 1 divided by, and negative sine of pi is a 0. Which will give minus 1 is a minus 2 over a negative 0. The negatives can cancel, and it can be written as positive 2 over 0. But that 0 in the denominator is not actually a 0. Since x is only approaching pi here, does not reach a pi. But a limit result of a non-zero number divided by 0 equals to either positive infinity or negative infinity, where the sign of the infinity often depends on the side the limit approaches from. We therefore have to work out the one-sided limits separately. So we have the left-sided limit indicated by the negative superscript on pi. Of the original. And the right-sided limit indicated by the positive superscript on the pi of the original. Let's start with the left-sided limit. We can multiply by the conjugate. Put 1 in the numerator as well, form of 1. Just like what was done above. In the numerator, those are not conjugates. We will not distribute. In the denominator, they are conjugates. We will FOIL that out, given the Pythagorean trig identity as above. The numerator will stay the same, but the denominator will become a negative sine squared of x. We can cancel the sine of x in the numerator with one of them in the denominator. Giving what's left is a cosine of x minus 1 divided by a negative sine of x. X is approaching pi from the left side here. The left side of pi means less than pi. On the unit circle, less than pi but near pi, we'll put it in the second quadrant. Sign in the second quadrant is a positive, so we can replace the sign of pi, which is approaching to a 0. The sign of x can be replaced with a positive 0. Pi can then plug in for all remaining x's, which will give a cosine of pi minus 1 divided by a negative of, the sign can be replaced with a positive 0 as x approaches pi, sign approaches 0, but it stays positive the whole time. Cosine of pi is a negative 1 minus 1. A negative of a positive is a negative 0, so it's negative 2 divided by negative 0. Negative over negative is positive. Non-zero over 0 is an infinity, and there is the result of the left-sided limit. The right-sided limit can be worked out in a similar fashion. Starts with multiplying by the conjugate over itself. We will not distribute in the numerator. We will FOIL in the denominator. We have the identity for the denominator. The numerator will be left as is. The identity in the denominator becomes a negative sine squared of x, just like the left-sided limit above. The sign in the numerator can be canceled with one of the signs in the denominator. Leaving cosine of x minus 1 divided by negative sine of x. X is approaching pi from the right side. The right side of pi means larger than pi, but near pi. On the unit circle, larger than pi but near pi, we'll put it in the third quadrant. Sign in the third quadrant is negative. Sine of pi is a 0, so it's approaching 0, but it's going to remain negative the entire time, so the sign of x can be replaced with a negative 0. Pi can plug in for all other x's, giving cosine of pi minus 1 divided by a negative of, sign can be replaced with a negative 0. Cosine of pi is a negative 1 minus 1 over negative times negative is positive 0, which will give a negative 2 over a positive 0. Negative over positive is negative. Non-zero over 0 is infinity, and there's the result of the right-sided limit. The two-sided limit depends on the results of the one-sided limits. They do not match. So the two-sided limit up above here will be does not exist. And there's the result of the three different limits.